Here we go. We are going to start on something today called trigonometry. And not to put any undue pressure on you, but this is probably one of the more relevant topics that we will cover in geometry. It's something that you're going to do for the next 4 years and probably through most of your college years if you go into some type of science. So it's kind of important. But I'm going to try to break it down as carefully as possible. So, given the fact that this is a difficult topic, given the fact that I won't see you on Thursday, if you have any questions while I'm going through this, you need to ask, okay? Don't be bashful about stopping me and saying, wait, where did you get that from? Okay, so in parentheses, I'm going to put the word right, or the words right triangles. What we're going to do today only applies to right triangles. So the first question you want to ask yourself, is it a right triangle? Is there that little box in the corner? Are you told that one of the angles is equal to 90 degrees? Is there something in the problem that indicates that it's a right triangle? If there isn't, then you're done. You can't apply this stuff. Okay? And there are 6 trig functions. We're only going to do 3. And they are the following: the sine function, the cosine function, and the tangent function. And they're abbreviated like you saw in your calculator. The sine is abbreviated SIN, the cosine is abbreviated COS, and the tangent function is abbreviated TAN. Do not call them sin, cos, and tan, because people will just laugh at you. And they're functions. They're just like every other function that you work with. Okay, you put in a number, it does some stuff to it, and it spits out another number. The best thing about this is all you need to care about is that these are simply ratios. And you'll remember from what we talked about the last time, ratios are a fraction of one number to another number. Okay, keep that in the back of your mind as we're working through these problems. Okay, so demonstration purposes, we need a triangle. So let me fire up a triangle here. It's got to be a right triangle. So I've got this right triangle. We'll put the right angle down in the bottom so that we know it's a right angle. And we need some sides. So let's call this A, we'll call this B, and we'll call this C. And we need an angle. So we're going to use this angle down here. And it's about time that you guys started learning the Greek alphabet because it's important. So our first Greek letter that we're going to deal with is a theta. Okay. It's a circle with a line through it. Again, it's called a theta. We'll get probably 4 or 5 Greek letters in today. It's common practice in these types of problems to refer to the angle by the Greek letter, by a Greek letter. We don't have to do that. We could just call this angle A because if you remember when we labeled triangles, we would know that that was A. But we're going to skip that and stay with theta. Okay? So when dealing with that triangle and the angle, you want to be able to answer a simple question. And that simple question is, if I pick one of the sides, how is it related to the angle? And what I mean by that is there's 3 choices. There's the opposite side, there's the adjacent side, and there's the hypotenuse. No other options. Okay. Hopefully by now you can all find the hypotenuse. Maeve, where's the hypotenuse in this triangle, A, B, or C?
C.
How do you know that?
Because it's the longest side.
Good. Do you know another reason why that's the hypotenuse?
It's not part of the right triangle.
Good. Perfect. Couldn't have said it better myself. Okay, so that should be the easy one to find. Like she said, it's the longest one, longest side, or it's not part of the right triangle down here in this business. Okay, that one's easy. Check. Brendan, what does the word adjacent mean?
Like they're across from each other.
Nope, that's what opposite means.
Like they are next to each other.
Bingo, next to each other. So Brendan, if we talk about this angle theta, which side is adjacent to the angle theta?
C.
Could be C or
B.
Or B. Correct. So how do we know which one it is? Well, I'm going to answer my own question. Maeve already told us that C is the hypotenuse, so therefore it has to be B. So the adjacent side would be the side that's next to the angle, but not the hypotenuse. Okay, so we got that taken care of. And then the third possibility is the opposite side, which would be the side across from the angle. Okay. If you can do that for any angle in that triangle, then trig will be a cakewalk. Because that's all you need to be able to identify. Opposite, adjacent, or hypotenuse. Okay. So just for practice, let me change something here. Let's get rid of this. We don't want that. Let's change colors. We'll go to pink. And we'll put this angle. Okay, new letter here. We're going to use alpha, which looks like a fishy. Izzy, you ready?
Yeah.
Okay, which one is the hypotenuse, A, B, or C? That's an easy one.
C.
Good. Which side is opposite for alpha now?
B.
Good, and which one is adjacent?
A.
Done. Good. Excellent. Perfect. We're good to go. Any questions on that, kids? Beautiful. Okay, we're going to go back to theta then. I'm going to put theta back in the picture so that we can define these terms. Okay, so these are, like I said, they're trig functions. And we take the sine, cosine, and tangent of something. So I'm going to change my notation a little bit. We're not ever really going to write out the proper names. We're going to do something like the sine of theta, the cosine of theta, or the tangent of theta. Okay. You have to take the sine of an angle, the cosine of an angle, the tangent of an angle. Just writing this doesn't make any sense. Okay? So, as I mentioned, you just have to realize that these are ratios. Okay? So by definition, the sine is defined as the opposite side over the hypotenuse. In this particular triangle, we said that based on theta, the opposite side was A and the hypotenuse was C. Okay. And again, let me reiterate. This is only for this triangle. That won't always be the case. I'm just listing it because we're using that as an example. This stuff will always be true. Okay. Cosine is defined as the adjacent side over the hypotenuse, which again, based on this triangle, would be B over C. And then last but not least, the tangent is the opposite over adjacent, which in this case would be A over B. Okay. Brendan, can you mute yourself, please? Okay, again, these only work for this particular triangle and that particular angle. Let me stop for a second and check to make sure you're with me. Are we good? Okay, good. I'm seeing some thumbs up pop up, so that makes me happy. Okay, so I'm going to take this and move this up here. Get this out of the way, put that down there. Okay, so question number one when we're solving the problems. Is it a right triangle? If the answer is yes, then we're good to go. Step two. I want to look at the sides. Okay. By looking at the sides, I mean determining what we already did. Are the sides that we're talking about opposite, adjacent, or hypotenuse? Step three. Once you answer step two, then you can answer the question, which trig function? And this will make more sense when you see me work through a problem. Step four. Okay? And again, steps 1 through 4 will make more sense when I start diving into some examples. All right, are we good? Moving on.
Wait, can you hold on for a second?
Sure. I'm actually going to erase this stuff because we don't want to get it confused. Let me know when you're ready.
All right.
Okay, good. All right, let's start with an example here. Let's take a pink triangle, and we'll make it a right triangle just to be sure. We'll put 25 degrees down here, and we'll make the hypotenuse 13, and we'll call that x. Okay. So notice, this isn't Pythagorean theorem. I don't have enough information to apply Pythagorean theorem. Pythagorean theorem requires 2 sides. I only have 1 side. And so I'm going to continue in this lesson to continue to go through the 4 steps. It's going to become tedious after a while, but the more I do it, the more I think it will start to sink in. Okay, so question number 1, is it a right triangle? The answer is yes, because it's got the little box down in the corner, and that would be silly not to do it as a right triangle. Number 2, sides. Okay, so my 2 sides I'm dealing with are the x and the 13. Let's start with the x. Let's see, who are we going to pick on today? Joey, is x adjacent, opposite, or hypotenuse?
It's opposite.
Perfect. Is the 13 adjacent or hypotenuse?
Hypotenuse.
Good. So that takes care of step 2. Step 3, which function then uses the opposite side and the hypotenuse, Joey?
Sine.
Good.
Is that how you say it?
Yep, that's correct. If we go back to this picture, the sine is the opposite over hypotenuse. Very good. We can also look at step 3, which trig function? We got that. We got the sine. So we set up an equation. The sine of the angle, 25 degrees, is equal to x, the opposite side, over the hypotenuse, 13. Any questions about that? Beautiful. Then we solve. Well, how do we solve? We multiply both sides by 13. I don't know where my n went. Notice I moved the 13 out in front. The reason I do that is because if I wrote it this way, sometimes people have a tendency to confuse that as this, and we don't want that. We want the 13 out in front. Now, this is where you pick up your handy-dandy calculator. You do 13 times the sine of 25, close parentheses. And Natalia, tell me what you get for an answer, please.
Do you want me to put it in my calculator?
Please.
Okay. I got 5.4940374743.
Outstanding. We're going to abbreviate that, or we're going to round that to 5.5. Well done. Okay, any questions so far? We're going to continue to do that over and over and over again. Okay, so let me change colors here. And let's suppose I asked now to find z. There are a couple different ways that you could find z. One way to find z would be to go back to Pythagorean theorem, because now we know that this is 5.5. And so we could do Pythagorean theorem. Z squared plus 5.5 is equal to 13 squared. I'm not a fan, though. You heard her rattle off all, I think there were 10 digits, 5.494037403. Even that is an approximation. 5.5 is an approximation, so if we did Pythagorean theorem, we'd get an approximation for z. I'd like z to be as accurate as possible, so I'm going to stay with trig. And I'm going to do this one. I'm going to take you through step by step how I would do it again. It's still a right triangle. This is the adjacent side. This is the hypotenuse. Adjacent and hypotenuse is cosine. Cosine of 25 degrees is equal to the adjacent side over the hypotenuse. Solve for z. Pick up my handy dandy calculator. 13 times the cosine of 25 gives me 11.8. Okay. Marcus, how big is that angle?
I'm not sure. Give me a second.
Okay.
65.
Perfect. Why? Why?
Because if you get 25 and 90 added together and subtract from 180.
Excellent. Okay. Now that opens a whole new can of worms. I could have solved this entire problem in a different way using the angle 65 degrees. I'd set up different trig equations, but it would do the same thing. Notice that this angle and this angle always add up to 90 because you have this third angle there, and together they have to be 180. You don't have to involve the 65-degree angle, but at some point, we're going to eventually get to problems where we're solving for all the components of the triangle, and you should realize that that is 65 degrees. Okay? Questions? Beautiful. All right, so we've got, let's see, we've got a building. And we've got a ladder leaning against the building. And we're going to assume that the building is perpendicular to the ground. And I know that it forms an angle of 40 degrees with the building. And I know the building is 35 feet tall. How long's the ladder? Okay, solve that. Go through the 4 steps, set up your equation, solve the equation. Before you even start the problem, will x be bigger or smaller than 35?
Bigger,
Why, Nora?
because x is the hypotenuse and the hypotenuse is the biggest.
Well said. Okay, go ahead, solve that problem for everybody, I mean. All right, Aiden, you're up. What do you got?
I'm pretty confused.
Okay. What have you done so far?
I was just like pretty much just like named all the like numbers.
Okay, good. Let's start with that then. So we already cheated. Nora told us that x is the hypotenuse. The 35 feet, is that opposite or adjacent?
Adjacent.
No.
Opposite.
Well, yeah, it's opposite because it's across from the angle. Okay. So opposite and adjacent is which function? Sorry, I said that wrong. Opposite and hypotenuse is what function?
Is it the COS?
No.
No.
Here. Opposite and hypotenuse is what?
Oh, it's SIN.
Yeah, sine, correct. Okay, so knowing that, set up an equation for me. The sine of 40 degrees is equal to?
X over 35.
Are you sure about that?
Or, I mean, the other way around.
Are you sure?
I'm not 100% sure.
Okay, so take 2 seconds and think about it. And what is it, 35 over x or x over 35?
35 over X.
Good. Okay. Now, solving this, I'll take you through the steps, but then I'll show you all a trick because this is going to happen a lot. I would multiply both sides by x and then divide by the sine of 40. Okay. Type that in your calculator. Tell me what you get for an answer, Aiden.
0.8136. Wait.
No.
Wait. 54.4.
That's better.
I accidentally had a sign in front of my 35 when I typed it in.
No, you're crazy.
54.4503339.
Okay. We'll go with 54.5 feet. Okay, good. So, getting from here to here is a fairly common practice where the variable that we're looking for is in the denominator. And you see how I did it algebraically, but you should also recognize what happened between these two values. Okay, so I call this a switcheroo. And if you want to save yourself some hassles, you can recognize the fact that the sine of 40 and x literally just switched spots. They switched locations. Which means you can skip that step if you want. You don't have to, but it'll prove to be quite a bit faster if you just recognize the switcheroo. With this problem, we could go on then to find out how far the bottom of the ladder is away from the building, either using Pythagorean theorem, which I wouldn't be a fan of, or setting up another trig equation. Okay? How many people think they have this? Give me a thumbs up if you do. Okay. For those of you that didn't give me a thumbs up, how many of you are shaky but think through some practice you'll eventually get this? Okay. And if you didn't give me a thumbs up, I guess I'll just ask, who's completely lost? Good. Not a single thumbs up. Okay. Questions? All right, so then let me give you another problem to work on. We'll take about a 5-minute break, and in that 5-minute break, you can solve that problem and get up and stretch your legs, use the restroom, do whatever you want to do, and then we'll come back and go over that problem, and then we need to change something else with the trig problem. Okay, so let's take this triangle and we'll put that down there, and let's make the hypotenuse 18, and we'll make this angle 23 degrees. Solve for x, solve for y. Get them both. It is currently 11:55, so at 12 o'clock we'll come back together and we'll have some people help us solve those problems. Any questions before I cut you loose? No? Great, go. I'll be back in 5 minutes. Okay, we're back. Let's go. Ella, would you like to solve for x or y? Which one you feel better about?
X.
X, okay. So, tell me what equation you set up to solve for x.
I was still like thinking about which one to like how to set that up.
Do you have x or y?
No.
Okay. Philip, W. X or y?
Y.
Okay. What equation did you set up for y?
I did cosine 23 equals y over 18.
Perfect. 18 times the cosine of 23 is equal to y, and what'd you get for an answer?
16.6.
Can somebody confirm that, please? Okay, I got a confirmation. Beautiful. All right, Philip, let's stay with you. How did you find x then? What method did you use?
I did sine 23 equals x over 18.
Perfect. Assuming you plugged it into your calculator correctly, you got x equals
7.
7 exactly? Can somebody confirm that also? Something pretty close to 7?
Yeah, it was 7.
Yeah.
Yeah.
Okay. Good. We'll go with it. Love it. Any questions for Philip about how he solved that problem? Awesome. Well done. Okay. That's the basis for trig. And so you're going to go through that over and over and over again with different scenarios, solving for the hypotenuse, solving for the opposite side, solving for the adjacent side. One issue we haven't addressed is what happens if we don't know the angles? How can we find the angles? Can we find the angles? Well, the answer is yes, we can find the angles. It just requires a different approach. Let me rephrase that. It requires a little bit extra in the approach. So the setup is very much the same. The 4 steps are very much the same. It just requires one little tweak that I'll show you in a second. So let's suppose I've got a triangle that's 5, 12, and 13. I know that's going to work because 5 squared is 25 plus 144 is 169, which is 13 squared. So we're good. And I'm going to solve for this angle. New letter here. Let's go with a beta. A beta is a capital B with a tail. And I want to find beta. For discussion purposes, let's get rid of the 12. Let's pretend we don't know that. We can go and solve it if we have to, but we're gonna just focus on having those two sides. Okay, so the process is the same. You set up the equation the same way. Solving it is the only thing that changes. So I'm going to go through the 4 steps again. Is it a right triangle? Yes. What sides do I know? Well, the 5 is the opposite side. The 13 is the hypotenuse. Which function is that? Opposite and hypotenuse would be sine. So then I set up an equation. The sine of the angle, which I don't know is beta, is equal to the opposite side over the hypotenuse. There's a reason why I left a gap there between the equal sign and the 5/13. I'll get to that in a second. Okay. Before I go any further, any questions? This is just what we did. The only difference is I don't know the angle measure, so I just put beta in there for the angle. So we're good to go. Okay. Earlier, I talked about something called an inverse function. So if we have something like x squared, its inverse function would be the square root of x. Why? Because they undo each other. Okay. Multiplication's inverse function is division. Addition's inverse function is subtraction. You get the idea. It's the function that undoes the function. The same is true for the trig functions. As I pointed out on your calculator, above the sign button, it says sign to the negative first. That's the inverse trig function of the sign. It's not a reciprocal. Okay, just so you know, it's not the same thing as 1 over. It's just a different way of writing the inverse function. It undoes the sine function. So my goal in this problem is to get beta by itself. In order to get beta by itself, I want to take the inverse sine of this mess. Because the inverse sine and the sine will undo each other. However, according to algebra, whatever I do to one side of the equation, I have to do to the other side of the equation. These two puppies will cancel. So the left-hand side reduces to beta. And this, I type in my calculator. So do that, please. Type that into the calculator to make sure you know how to do that. Be careful with your parentheses. And Brooke, Paul, tell me what you got.
I got 22.6.
Perfect. And those are degrees because it's an angle measure. Okay. So as I said, everything is the same except for the solving part. And the solving part involves using that inverse trig function. Brooke, let's go back to you. How big would this angle be then?
67.4 degrees.
Perfect. Because that angle beta and that red angle have to add up to 90. You said 67.4. And we know that that's 12. Notice now, after doing a little bit of work, I have all 6 parts of the triangle complete. That's called solving the triangle. You know all 3 sides, you know all 3 angles. Questions about that? Each one of the 3 trig functions, sine, cosine, and tangent, have an inverse trig function. Okay, so let's go back to the ladder against the building. So now I have a 50-foot ladder leaning against a perpendicular building, and I know the base of the ladder is 10 feet from the wall. Let's go with gamma. Fishy standing on its head. Solve for gamma, please. Wait, let's make this a 2-parter. Let's solve for gamma and how tall is the building? Let's call that H. I know I'm going fast, but I want to be sure to get this done. Lexi, can you help me out, please? I know you probably haven't finished it yet, but what equation did you set up to solve for gamma?
I didn't really know like which equation to do because I think since 50 and 10 are next to each other, would you do 10 over 50?
Yep.
The cos?
Good. So the cosine of gamma is equal to 10 over 50. Perfect. Actually, you know what?
Could you simplify that or no?
You could, but you don't have to. In fact, just to demonstrate that, I'm not going to. You could do it as 1/5, yes. But I'm going to leave it like that, and you'll see how we get the answer. Lexi, do you know where I go to from here? What do I do next?
I think you do the inverse sin.
No.
I mean inverse co on both sides.
Right? Okay, this is going to cancel, so that leaves me with gamma. This you type into your calculator. So somebody do, or all of you, do the inverse cosine of 10 divided by 50. What do you get, Lexi?
I haven't put in my calculator yet.
Ooh.
$78.46 or 78.5.
Perfect. Okay, that's pretty steep, by the way. You probably wouldn't want to go up that angle, or that ladder. Okay, so instead of actually doing part 2, let's talk about all the different ways that you could solve part 2. You could just do Pythagorean theorem. 10 squared plus 8 squared equals 50 squared, which is probably what most people would do. And that's an okay calculation because it's exactly 10 and exactly 50, so I wouldn't have a problem with that. However, now we know the angle. So you could set up a trig equation involving the angle. For instance, the tangent of gamma is equal to h over 10, or the sine of gamma is equal to h over 50. You've got a couple different options there. If you are feeling crazy, I don't know why you would do this, but you could go and solve for that angle, which would be 21.5, and use that angle to do the calculations. You have a couple different ways to solve those problems.